Wonderful. Well, welcome everyone. I'm really pleased that you could join us today for the CBI consultative webinar on new technologies. My name is Karen. I'm the program coordinator for CBI. I'll lead today's webinar in collaboration with my colleague Tina. And we're very excited to introduce our new partners from the SDG AI Lab in this webinar, Gökhan, Jonas, and Martin. I would also like to take this opportunity to thank them for joining forces with us to advance disaster management through new technologies. Now, given the volume of people on this call, we won't be able to do individual introductions. So I'd kindly ask you, everyone, to click on their name and add their organization if you haven't already done so we can all get a feel of who's participating and if you want to reach out directly to people or to the group. So what we can expect from today's webinar is that you will become familiar with our collaboration with the SDG AI Lab. You will also learn about the key objectives of the planned work, the desired outcomes, the structure, and the next steps. We aim to go through some basics of key technologies that can be applied and their potential use within the CBI context. You can also share needs, use cases, and experience with us to establish common ground for the research. And finally, you can express your interest in engaging with CBI in this work stream and how we can best support you. So today's webinar is rich in content, and we look forward to learning a lot today and continuing in the future webinars and bilateral discussions. This is just the beginning. So there's going to be a lot of opportunities to engage with us as the project evolves. After this, Gökhan, Tina, Jonas, and Martin will present the planned work and conduct a short Mentimeter exercise to hear your views. We'll then have short presentations from two of our CBI networks, the Philippines and Vanuatu this morning, and then we'll open the floor to other networks and all participants for comments and questions. You can also use the chat function during the presentation to ask questions, and we'd encourage you to do that so the presenters can address any questions you might have. And then after that, we'll have a brief closing with next steps. With this, I'd like to thank everyone for joining us today. We have a lot to get through, so without further ado, I'm going to hand over to Tina. Over to you, Tina.
Thank you, Karen. And I'm going to just provide a very brief introduction. And our webinar today, Jonas, if you can skip the slide. Our webinar today falls under CBI's work on innovation. And we all know that innovation is a very broad concept, and new technologies, they are only a part of it and enabling some of innovation. But it can also innovation can also relate to many other things that do not have anything to do with technology, can relate to processes and other things. But however, with the fast development of technology, they also have a very important role in disaster management innovation. And today we are focusing especially on the potential new technologies, as we have this very concrete and exciting opportunity to take our work forward thanks to our partnership with the SDG AI Lab team. And regarding the background for this work at CBI, in 2017-18, we realized that many of the CBI member networks were innovating and creating partnerships to use new technologies. For example, in Sri Lanka, the network teamed up with the local taxi hailing app PickMe and tailored it for flood rescue using location data. In the Philippines, we saw that PDF was doing a lot, for example, with startups to innovate around solutions for disaster management, and many of the networks, we realized, are using also communication technologies for early warning or conducting rapid needs assessments after a disaster. And as we were a much smaller team back then, we mainly focused on collecting and sharing some of those examples from the networks. But we always knew that we need to do much more in this area. And there was a lot of potential for CBI member networks and their counterparts also to advance this work. So last year, the Boston Consulting Group conducted a number of interviews for our strategy refresh process. And they found that exactly that CBI member networks innovate organically and out of necessity to improve their operations and effectiveness, and some innovate on very simple and practical models, and some are also very disruptive as well. So, and they also suggested that CBI can play a great role in supporting and elevating the network level innovation through a coordinated approach that uses a broad range of local and global sources, and fostering this inter-network sharing and encouraging testing and learning culture. So this year we wanted to take these recommendations forward, and we teamed up with the SDG AI Lab on the use of new technologies for disaster management. And you will hear more about this plan, what we are going to do together from the colleagues shortly. And we very much want to hear your views also, how we can best use this partnership for your benefit. So before that, let me also mention that we do acknowledge that often it is the government or other lead entity who is leading the national efforts in disaster management, including the use of new technologies. But we're looking at this area quite broadly to really identify the different entry points for private sector networks and private sector, so that they can be supporting this work of building better and efficient and more cost-effective systems for disaster management. So I'm very much looking forward to this as an interactive session today, and please join us in this brainstorming how we can best make this research and work benefit that we serve the people in need after crisis, and to prepare and to respond better. Thank you, everybody. So over to Gökhan to provide an introduction about the SDG AI Lab.
Thank you, Tina, and I would like to welcome you all to this joint webinar. My name is Gökhan Dikmener, and I work as a technical specialist for IICPSD, and I oversee the work of SDG AI Lab. For SDG AI Lab, it's a pleasure to work with Connecting Business Initiative and the CBI networks all around the world. Our partnership and collaboration will be a key step in advancing the understanding and use of frontier technologies in disaster context. So I would like to thank also CBI one more time for this. And I would like to briefly introduce you the SDG AI Lab. This will help contextualizing the institution and also the work that we are conducting under the lab. It is a joint initiative of 3 UNDP units: Nature, Climate and Energy Cluster, Finance Sector Hub, and Istanbul International Center for Private Sector in Development. And the lab is hosted under Istanbul International Center, IICPSD. We have 2 main objectives. We basically implement frontier technologies such as AI, ML, and GIS for sustainable development. And we also aim to strengthen UNDP's and its stakeholders' capacities for the increasing demand for the use of these technologies. Next, please. We have, like the other lab initiatives, we have 3 main streams of work. Research, our landscaping and mapping study with CBI is a good example of this, and we will discuss this in this research today. And under development, we implement digital development solutions for SDGs. We will also have a solution development exercise with CBI networks under this partnership. And as a last item, we also provide technical advisory to UNDP units in their activities with our in-house team, and we also help developing partnerships with the global tech companies. And in the next slide, I would like to give a snapshot of our activities for you to better visualize our work. For instance, we work with CBI on this very interesting research and development activity about the use of frontier technologies in disaster context. And with DCTA, for example, another similar initiative of UNDP, Business Call to Action, we work on visualizing their progress reports from their members with an interactive dashboard. There are more than 250 members, and they have reports from last 5 years. And with Nature, Climate and Energy team, we process their project documents with 5 major environment funds, and we extract information and insights from over 1,000 documents. We also support UNDP projects like Reef to Resilience in analyzing coral reef health to formulate a disaster insurance. So these technologies can be used in very diverse areas. And SDG AI Lab is capable of supporting UNDP and its stakeholders in their endeavors. And we also have a volunteer data scientist initiative that allows us to mobilize the necessary talents to your project in a very affordable and efficient way. Without further delay, I would like to give floor to my colleagues to start discussing our joint activity. Thank you. Over to you, colleagues.
Hi, sorry, I was on mute. Thank you so much, Karen, Tina, and Gökhan for your kind introductions. So again, I'm Jonas. I work for the SDG AI Lab at UNDP as a data scientist, and I'm really excited to meet all of you today, electronically at least, and to give you a little bit more, there we go, a little bit more details about our ongoing research and development with the CBI team. So before diving in, something I want to do is to emphasize again why it's important to meet here today. And I just want to give you some statistics and facts to begin with. So alone between 2010 and 2017, we recorded over 350 disasters, 68,000 deaths, 210 million people affected, and at least 153 billion US dollars in damages. And just in 2017, 102 countries were affected by disasters. So that's the one side, and then the other side, that's the side I'm coming from. We are at a breakpoint of digital advancement. Just in the last 5 years, 90% of the worldwide data was created, and there are already 40 times more bytes of data than stars in the observable universe. So technologies become more accessible as well. And in the light of all these increases, algorithms already advanced to have nearly ubiquitous impact on society. So in general, we are here to make use, that's our job, of this newly existing technologies to support disaster preparedness, response, and recovery, and to also make it a little bit more accessible for the networks. So of course, it's very important to understand what technologies are relevant and what do we want to cover. So we have this list of technologies we were just coming back to because they repeatedly came to us in doing our research. And I just want to give you a very brief definition of all of them so we just have like a common understanding. So let's start with 3D printing. 3D printing is the process of making a physical object from a three-dimensional digital model. So this is used, for example, for printing medical devices, and it already scaled to printing whole houses now, infrastructures. Then, of course, we have AI, which encompasses machine learning, computer vision, NLP, all those things. So this is kind of the expertise I'm coming from. And it's probably also the thing we're going to look at the most, I guess. And for me, it's basically, we can define it as teaching computers to mimic human behavior. And we do this by using past examples and experiences. Then we have augmented reality and virtual reality. We can use this, for example, in a training concept that you want to learn how to repair a vehicle, and you do this in a virtual space. You don't even need to be there anymore. Then blockchain, I'm going to talk about it later a little bit. Cloud computing. It's like one of the greatest advancements lately because it allows us to access physical goods without owning them. We can access computing power, storage, and servers. So it really, really pushes the whole field forward. Then we have communication networks, the technology that enables communication over different locations with 5G as the more recent advantage. Then crowdsourcing, engaging a lot of people in a common goal. Cyber physical systems, it's basically kind of the end goal we want to achieve. It's kind of a computer system, and the mechanism is controlled by an algorithm, not by humans anymore. Then we are going to talk about drones. And here we mostly talk about, I think, aerial vehicles. And drones can be used to just bring goods from A to B, very simple but effective, but also to take pictures and to assess damages. GIS, we have Martin in the call, so I'm not going to spend time talking about this. He's going to do it for us. Internet of Things, you can basically see it as a thing to combine many sources of information and aggregate them. I can give you an example later. And remote sensing, for example, we can use drones to measure seismic or hydrological activities and then build early warning systems. And of course, social media, that's a little bit my expertise. It's everything related to text in Facebook and Twitter and YouTube and all the online forums. So to make sure it's a little bit more accessible, I also want to give you some use cases and to show like what we are aiming for to do. So for example, talking about hurricanes, cyclones, typhoons, key technologies can be GIS, AI, drones, social media. So for example, drones are used to just transport relief goods from A to B. It's pretty easy, but it's super effective. Then, of course, like one of the most common use cases, damage and loss assessments. We can classify images from social media or taken by drones to assess damages after a disaster. Martin works on this, for example. Then we have floods. We can move into the prediction and preparedness phase. People use data to predict the probability that a flood will happen and then build early warning systems. It's already, I think, implemented successfully in India, Iran, and Myanmar. And also situational awareness. This is something for IoT, Internet of Things. We can combine many information sources, put it in a dashboard, and have like a real-time information gathering, and we know what's going on. Talking about conflict and fragility, something we did in our team internally, we did a social media analysis to understand the population sentiment towards a specific topic. I can give you also more information later because it's so short on time. Then also blockchain is repeatedly used as a payment system and alternative tool for distributing cash-based transfers. This can increase transparency and effectiveness by a lot. And then just something I just had to mention is, of course, health epidemics and pandemics, especially in regard of the current COVID-19 outbreak. So what people were already doing is to forecast diseases. It's done for dengue fever, flu, COVID-19 as well, by using search engine queries, social media, weather data, geographical data. And also we've seen all the tracing and tracking apps. AI is used with vaccine development by choosing the optimal patients for trials and also for disease evolution monitoring. So it's a lot of information, and I just want to emphasize that I could have added so much more technologies and basically used all of them from before. So for us, it becomes just so clear that there's so much going on in production, development, prototyping, and just ideas. So we need to very much understand the landscape before we can use those findings and help also the next to advance. So we are trying to scan and categorize them and to really, really understand what is going on. So now that I gave you a little bit more background, what we're aiming for, I think it's a good time to also understand a little bit what you're doing. So I'm really happy to have you here. So if you could go to the Mentimeter we prepared, it would be really great for us to understand which technologies you are using already in your work, and also what technologies you would like to learn more about, or maybe something you see potential in and you want to learn more about. I think everybody has the link, right? Maybe Tina, you can assure me on this.
Yes, so if you could grab your phones or on your computer, go to menti.com and type in this code 661774.
GIS, social media. We also have one other because there is like not one list that people agreed on. So we cannot just say those are the technologies and there's nothing more. So if there's anything else you're using and this is not in the list, please let us know. There's one, for example, so I'm very interested to hear about that later in the discussion, or to me by others. Social media, GIS, and social media a lot. That's great to see for me as an NLP expert. AI, cloud computing, crowdsourcing, and GIS, cloud computing. Drones, blockchain. I thought there's like a really interesting blockchain example from Vanuatu. There it comes maybe.
Very interesting to see that 13 are saying GIS, and also
yeah, and also social media. That's really interesting to see for me because that's like the field I'm gonna work the most on. So that's really great. So maybe we can really talk about this later as well. All right, we're so short on time. I think this is a little that's a good overview. So maybe we can go to the next one to understand also like what are you interested in learning more about. So maybe you already identified like something you want to make happen using technologies, but maybe you like lack access to data, or the data quality is not enough, so you want to learn more about that, or just like more about the technology. So please let us know about this as well. Drones, AI. That's really ensuring for me to see AI, social media, the things that I know the most about. That's great. Remote sensing. And others. That's great. We need to keep that in mind. I want to learn what other means. Blockchain. Sanya, I see you raised your hand. I don't know. 18. All right. Let me, 19. I think we can keep it open, but let me go back to the presentation so we can like stay on time a little bit. I think it's already a bit over time.
Yeah, the voting can continue. Great.
Yeah, exactly. So I'm gonna be fast now. Let me just like sum up what we're gonna do in the research. So we have this 1-year research and development being conducted by us, SHI Lab and CBI. And as I said, the research study basically aims to understand this landscape we were just talking about, to know what technologies are relevant, how we can use them for DRM, what challenges do we have, what opportunities, and then also do the same with the networks to understand like what needs do you have and what challenges do you encounter, what opportunities, and then bring it together and map it. And then also on top of this, we want to have some practical implementations. And I think this is really important to not only talk about it, but to also really start to work on it and have some hands-on capabilities to incorporate those knowledge into some prototypes. And we're going to have some webinars and of course interviews on the way. So this is just the start. And it will end with like a qualitative research report, the implementations, and of course the final webinar series. Those are some key questions. I think I covered most of them already. So maybe just something to add to stay on time is we also want to keep in mind how to use those technologies in an inclusive and responsible manner. So we want to understand what are the vulnerable groups to consider when applying technologies for DRM and how to make sure we can trust our results and confidently use them for decision making. So this is another dimension we very much going to keep in mind and add it to the research objective. So, all right, I guess we can now move on to maybe the more exciting part, talk about the prototyping and practical implementations. And as I said, we want to provide the hands-on applicable knowledge for us and offer the networks to build their own capacities. And we want to do this by basically producing 2 prototypes. And we have 2 streams, and we want to do one in natural language processing. So it's great to see that you already work a lot on social media, and you want to learn more about that, and also about AI, because this is going to be a pretty much AI-based as well. And of course, GIS, because it's just the key technology in DRM. And fortunately, we have Martin on the call, who is a GIS expert. So I would give the floor over to you, Martin, so you can walk us through the GIS technology stream. Thank you very much.
Yes, dear colleagues, hello. Can you hear me?
Yes.
Okay, great. So I'm very thrilled to present now, and I think the introduction of my topic has been very good because the Mentimeter showed already that we have some interest in this topic. And Jonas and I, we cover both of these topics, social media, NLP, and GIS. I'm on the GIS side of things. And I just want to give you a quick introduction to GIS. And to start things off, I want to fit the terms into the right categories. GIS is a data management system. It provides a framework for all kinds of spatial data formats, and it provides customized tools to analyze the context of geospatial data and extract valuable information. GIS is a discipline itself, but borrows heavily from computer science, which is its technical foundation, and it expands all kinds of disciplines like engineering and natural sciences and environmental sciences until social sciences, if you talk about social media, for example. We will give some examples on how these fields meet each other later and how it relates to the context of GIS-related research. But go back, please, the slide, because I'm still not done. The GIS framework encompasses 3 main fields, which could be treated as completely independent tasks. So first of all, the data collection side is done by a variety of different methods, starting from the most known thing that comes to our minds as satellites. Satellites are an important data source, but many more exist. To name a few, we can collect data with airplanes, we can collect data with field measurements. Social media is also a kind of recent way to extract information for GIS tools. Drones are also a very exciting topic, and we are working on this in the future. And any kind of data which is for us interesting has a geolocation, an attribute which tells its where it is in space.
Did we lose Martin?
Sorry for that. Sorry, I'm sorry. It's crashed. The website crashed.
No problem.
Okay, can you go back? Yeah, can you go
No,
back again to the previous slide? So the processing side is the extraction of information and the construction of models and generating new information. Processing encompasses the preparation of raw data as well as the final outputs of a study regarding poverty or any kind of other disaster we are trying to encompass. The third part is the displaying part, and this is always like the most important part of an output. And everybody's familiar with thematic maps, navigation systems, and images of deforestation. And most of these examples are very common to these users. And it's a core medium to communicate our findings to the users. Slide 2. As we move on, now to just deepen our understanding a little bit and to give a bit more concrete framework, we want to understand what drives the current development of GIS-based analysis. New technologies driven by digitalization of our societies and industries brings new possibilities in disaster risk research and mitigation. On the data collection side, we see improvements in all relevant dimensions. So to name these ones, in case of in a catastrophic event, for example, time, and I'm talking about real time, is often the most valuable resource. Image resolutions allow for more detailed analysis of damages. Flexibility through robots and flying drones facilitate the data collection even in difficult to reach environments. Finally, community-driven solutions such as crowdsourcing enable volunteers to contribute where machines reach their limits. The processing side has been enriched after decades of improvement in hardware and software. Powerful machine learning algorithms now reach personal users into their homes. For heavier workloads, cloud computing services enable complex and difficult computations. For the end user, information retrieval in an emergency situation can be life-saving. A fast and direct way of communication, vital information is a key element of disaster risk services in the near future. Slide 3. Yeah. To just name a few applications of the GIS technologies in the development sector and disaster risk management, we can talk about how the landscape has been changed by human interference and how people at risk move, how they behave in certain situations. The most pronounced examples, for example, earthquakes, tsunamis, disease spreading, storm surges, tropical cyclones, droughts, and refugee movements are a very recent topic and are very of high interest. The images on the right depict one example of drone footage collecting data about a refugee camp, and the bottom side is an agent-based model representation of the refugee camps in West Africa and how we predict the movements of the refugees in between these spaces. Can you move on? The next example I want to give you is a very illustrative one. It is about building detection with artificial intelligence. So we are able to extract the building footprints in a given moment in time in a city and draw polygons around these buildings. And later, in a time of devastating catastrophic events, such in Indonesia with a heavy flood, after we already knew where the buildings are and how many we have, we can actually predict and see how many people how many buildings have been lost, and we can assess the infrastructure damage after a catastrophic event. Can you move on? So now when we talk about facilitating the AI and technology in GIS, we are trying to enable this technology, and we understood that GIS is currently one of the core technologies in disaster risk management, and it utilizes cutting-edge machine learning algorithms for deeper analysis and better prediction models. GIS is a system for rapid emergency response if it's used right. The key considerations we have to make here, it requires technical specialists and expertise and often high quality data, but we are moving in this direction anyways, so we are improving these points year by year. Data availability and computational power are of great importance, and we are also seeing huge improvements in the sector. Thank you very much.
Thank you so much, Martin. Thank you so much. It was very interesting. So I'm just going to finish this with the NLP part. I'm going to keep it brief because maybe we can also put something in the discussion then later. So just to very much quickly define what NLP is, it's the subfield of linguistics, computer science, and AI concerned with the interactions between computer and language. So it's basically everything related to text data is related to NLP. Google search queries, text messages, news items, social media, again, forums, documents. We have to keep in mind that 70 to 80% of all data is text data, and it's just increasing. So this is like a trend. It's just going to become more and more. And text can preserve most complex and critical information. So for me, it's super exciting to work on text data all the time. It's a bit difficult, but it's a really, really exciting field. So to just give you some context, what we're already doing in my other projects. So for example, I work a lot on information extraction. I'm trying to extract information from long text sources. And this can be documents or also news articles or just like information I find in the internet. It's just like automated step. I don't have to Google it anymore, download like a text document and read through it. I can just build an algorithm that does it for me. Then I work on text classification. So for example, we're trying to map national development plans to the sustainable development goals to better understand what people are working on and like how the impact is related to the SDGs. Then text summarization. It's a little bit related to information extraction to just summarize long and tedious text sources. And then something that's my personal passion, I have to say, are chatbots and question answering systems. And those are also used like for emergency communication. For example, we had a chatbot with COVID-19, so we could just like answer very simple questions and get an answer. And we know the answer is accurate because like this thing is monitored. And to just like kind of like add like the next level to this. And I'm very excited to hear like what are you doing on social media, because social media is mostly text data in my opinion. So some things I found very interesting how people are already using it for disaster risk management. For example, we can use social media exchanges to detect sub-events during a disaster. So we not only look like at the big earthquake that happened, but we can see, okay, like there's like one specific bridge that collapsed and people are talking about this. Or there was like one small landslide and we can detect those things because people just like talk about it publicly. Then of course, outbreak of diseases, we already talked about this. Maybe like some very interesting use case I found was after the terror attacks in Paris. So I'm just going to talk about this quickly again. But people they were looking at this hashtag and they were trying to build algorithms to understand, is this just moral support? Or does it really mean that somebody offers shelter? So it's about like gathering actionable information. It's a super interesting use case. And then again, something we did in our team as well, we did this social media sentiment analysis to understand how people feel towards a specific issue. We did it for COVID-19 restrictions in Turkey, how people reacted to it online. And the underlying theme is definitely to process and extract information from unstructured sources. And I think that's also probably the main impact NLP can have for DRM, is to automate the information extraction. All right, I think I don't want to take much more time. I'm super happy to share more about my experiences and the use cases later in the round of discussion, but maybe we can move forward and hear more about the networks. So Tina, maybe over to you again.
Thanks, Jonas. Thanks, Martin. Very interesting background for us and sort of kickoff for our discussions. As Jonas was saying, we're moving next to the network example. So first we will have PDRF colleagues to speak about their work around new technology. So over to Veron and the team.
Good morning, good afternoon, and good evening for you guys. We have here our team from the Operations Center to talk about the technology that we are using in the Operations Center. Over to you, Erwin. Enjoy.
Can you just unshare the screen so that we can share our slide? Thank you.
Yeah, of course. Please.
Thank you very much. Hi, good afternoon and good morning to our panelists and our attendees for this webinar. I am Erwin Tolentino, the Planning Officer for the Operations Center of the GRF. With me is Joy Lim, our GIS specialist, and on my left, Mel Garcia, our Planning Officer as well. So we're going to talk about how PDRF is harnessing technology for its operation. And for its operation, PDRF is using technology, and at the heart of it is our platform called Handa for hazard and disaster analysis for business resilience. So we primarily use Handa for three of our processes, namely hazard monitoring, planning, and during response. So for the purposes of this discussion, we are categorizing our processes as internal and towards our network. So first, let's discuss how PDRF uses the platform for our internal processes. Just a brief background, Handa is a GIS-based platform with ArcGIS, powered by ArcGIS, that was customized specifically for PDRF. Now, for hazard monitoring, we send a screenshot of our dashboard, this picture that you are seeing, as our hazard briefer for the day. We send this at the end of the day so that our staff has an idea of what has happened during the day. Other notable technologies for hazard monitoring is through our partnership with PVOX. We are using their Rapid Earthquake Damage Assessment System, or REDAS, which readily gives us the data for earthquakes simultaneously as they are receiving the data. We are also utilizing secondary sources for information like EMOPS and Windy, and as well as social media. We have partnered with Facebook for their Facebook Data for Good, and we are also using Twitter Deck and following certain hashtags for certain hazards to monitor the information in the social media. Now, what do we do with that data that we have collected during hazard monitoring? We use it in planning, primarily in our PDRF risk assessment. So this determines the alert system of PDRF, whether we activate the EOC or not. Now, this flow chart in the slide just shows you how much have we done in integrating our risk assessment module in our Handa platform. Now, the blue parts are those that we have done already. We have conceptualized and set the parameters to be used in the risk assessment, namely the intensity of the hazards, the built-up areas where the population is concentrated, and the affected MSME in the area. Now, what do we need to do is to stress test this parameters so that it yields the best value or the best result for risk, and to build the model under ArcGIS. The next would be to integrate it to Handa, and that would automate our risk assessment for our activation. Now, since we are activated, we also use GIS and the platform for our response. Primarily, we use it to visualize and sum up all the data that the operations center has collated over its activation. As you can see in on the screen, we use dashboards for data visualization, and depending on the data that we collect, we customize this so that we can show our partners and our member companies the best data that we can show them. To further collect data, we also deploy teams and participate in rapid damage assessment and needs analysis, either with the UN or with the national government. And then we deploy our own Ardena form, which focuses on the private sector and MSMEs. We developed an online questionnaire for that under Survey 123, so that it can be readily visualized by the EOC, even if the assessment team is still on the ground. Now let's look at how Handa gives out information to the network. Over to you, Joy.
All right, thanks, Erwin. Hi to everyone. Okay, so as Erwin mentioned, the internal processes, I will be discussing about how we employ Handa to the PDRF network. So I was very glad to hear Martin mention that GIS is actually one of the core technologies in DRM. So that's actually what we employ right now. So one of the main features of Handa is the hazard monitoring application. So this is where the members of the PDRF network can actually access the various data that we have collected from national agencies. But then we take it a step further by enabling them to actually perform simple spatial analysis just within the app. So for example, they can import their own data as a parameter for the analysis, and then use the existing hazard data to identify which of these facilities are at risk to a certain hazard. So this allows the members to actually perform their own analysis on the fly, and they won't have to install applications or software. Next. Okay, so we also have the incident reporting and monitoring app. So this is another feature from Handa where network members can report incidents within their facilities. And this will be seen by us, the EOC, to coordinate response if and when necessary. So just to put things in context, Handa actually means ready or prepared. So that means that we want them to use this app to empower them to build resilience and hopefully prepare them for possible disasters. So I will be handing it over back to Erwin for future engagements. Thank you.
Now for the future engagements of PDRF, we are in the talks with Seismic AI for their early warning system, specifically for earthquakes. And during this COVID pandemic, SAP has reached out to us so that we can develop dashboards for our projects. This is the example for our project Kaagapay. Next, for the challenges, as the data clearinghouse of the network, we need guidance on proper management of information that is needed to provide timely, relevant, and actionable information to the network. Now, since after we settle on the data, we are in need of workshops and consultation sessions to improve data visualization using our current platform, Handa. Lastly, in the wake of the two strong typhoons this year, we are interested to learn about remote sensing for pre and post disaster analysis. With that, we end our presentation and thank you.
Thank you. That was super interesting. And I wish we had more time. We need to organize another opportunity to talk more in detail. So thank you very much, colleagues, for this example. In the interest of time, let's move to Glenn in Vanuatu to speak about their project. So over to you, Glenn.
Hey,
Jonas, if you could put up Glenn's slides, please.
Of course, 1 second.
Good evening, good morning, everyone. I'm Glenn from the VBRC. So just running through our, after TC Herald and COVID-19, we decided we needed a new way of distributing cash to those most affected, or just giving aid to those more affected. So we decided we'd launch an unblocked cash transfer system. If we can go to the next slide, I'll run you through how that worked. We took a common cash approach, which means that we wanted to create a basket opportunity where we could have different donor partners that could contribute by putting funds into a basket of like a trust fund that could be distributed equally amongst those selected. So what we wanted to do is ensure that those people on the ground, our field partners, were out there doing the assessments, could tell us those areas most affected. What it did by we partnered with Oxfam for this project. So we'd already done some designs and testing, Oxfam especially, through a couple of small settlements in Vanuatu to test that this would work. The system was built through a company out of Australia, and it was very, very simple technology using handsets in the field. $60 cell phone handset. That was what our vendors were using, and we were giving just an NFC chip embedded card that cost under 30 cents. That's what we were giving our recipients of funding. So the role of the VBRC in this project was to do the vendor support training. So we were selecting the vendors, we were training the vendors on how to receive it. Obviously from a low technology country like Vanuatu, we have 300,000 people. We wanted to empower our small vendors, our SME and MMSE. So we're talking areas that struggle to have decent roads, sometimes can only be accessed by boats. We wanted to select an end-to-end system where those that were receiving the funding would be able to get from their homes, their settlements, they would be able to actually get to the vendors. So we selected a range of vendors that went from the shops through to the transport, through to the telecommunications operators, right through to the end to the stalls and shops in town. We were ensuring coordination through the single platform gateway so that everyone could see, and if we go to the next slide, everyone could see how the funds were being spent. So the common cash approach, as you can see at the top, we had our national field partners, which were Oxfam, BBRC. We had, in terms of selection, was World Vision, Save the Children. We had the donor partners. They could see what was happening, where the funds were going. And the trust fund common pool that you're seeing down the bottom, we selected a local accountancy firm to actually run the distribution of the funds back to the vendors. So we used a KPMG associate, which is Barrett and Partners, and the FSP financial service partner was National Bank of Vanuatu. And then it was a very simple system where we were using the blockchain-backed technology. It was doing a reconciliation overnight, and the recipients would receive their cash on their card and they could spend it at any one of the vendors. It made it very, very simple for everyone to transparently see it. If we can go to the next slide, please. Why use this system? That's an actual screenshot of that's the handset that was used, and that's actually what the people see, so they could check their balance at any time, what they'd spent their funds on, where they'd spent it, and what was available. Next slide, please. And this was the key section where the blockchain technology is used. All of the donor partners, so the key donor partners for our rollout was New Zealand government and Australian government, so DFAT and MFAT. They could log in at any time and they could see who was spending the money, where it was being spent, what type of goods and services. So you can see at the top, we broke it down into some key categories. So we had long life food, household items, hygiene items, fresh food, and then we've got medicine and just day-to-day bills. So we could see how it was working. And what we found is that generally it was about 70% of the households were managed by the female in the household. So the matriarchal side of it was coming through. They were the ones spending it and managing the cash. If we go to the next slide, we managed to distribute to just over 7,000 households. So we chose those households that were in need of it. We were giving approximately in US dollars, 110 US dollars for a period of 6 months. So that's per month over 6 months. And so that was giving them the basic necessities. We had as you can see, the split between Tropical Cyclone Harold and COVID. COVID was obviously more affected because of the loss of jobs. So we were going through into those areas that most needed it. The selection was done by affected household calculation, and we had to be quite hard on it because of the number of the funding that we had available, because this was being run as a test case. If the ease of the system is the more money that donor partners give or the government gives for the response, the greater number of people that we can get to, or the longer that we can run the response for. So out of the whole project, what we're rolling out to another province now. We have a proof of concept in the province, in the Samar province, where we've run it out, which is the largest province of Vanuatu. They had TC Harold go right over the top of them. It was a Cat 5 cyclone. So there was a lot of damage there. All the vendors and the communities in that area and the main townships now know about the Unblocked Cash project system and how it's working. It's developed immense credibility. So we know that people are spending it on the right amount, on the right items. We know that there's in the communities themselves monitor what it's spent on. So there was, over the years, we've seen talk that the money would be spent on inappropriate items. We have no limitations on what they can spend it on, only the vendors that it goes to, but we've found very, very, very little misuse of it. So now that we're looking at rolling it out as an ongoing platform for humanitarian response with DFAT and MFAT, they've recognised that there's some key benefits in doing this. While you've done an initial push with maybe essential food items and water, some shelter needs, within the second week of a response, we think that the cash response is much more efficient because people can spend the money on what they actually need. Every household is different. So and it takes away any form of grafting in terms of loss through government or less scrupulous vendors, and it's easily monitorable. So overall, the distribution of the cash has been very, very, very well received, and it's a simple system to roll out. On a cost basis for this original push, it's been a little bit more expensive than what we'd like to roll it out, but it's because we have been testing the technology. We think within another 30 to 60 days, we'll have it pretty well defined on how it works, and we'll have a model that can be rolled out beyond Vanuatu using this technology. Oxfam just received a big grant because of the use of this technology. They just run the award, you probably saw. So it's gone very well. So that's it from me in Vanuatu. If anyone has any questions, you can go to the Facebook VBRC, the Vanuatu Business Resilience Council, and there's a video up there of the recipients that have received it, and also how we used it in the field, and you can see the location there. So that's it from me. Thank you.
Thanks so much, Glenn. Super interesting. We can also post the link to the video in the chat here, so everybody can find it easily. Without further ado, knowing that we are running a bit short of time, I'm going to open the floor for any further experiences, questions, and comments. So anybody, please indicate your interest, and maybe you can indicate in the chat box if you want to speak, and we can provide, we can open your mic.
Have we already received some questions, Tina? I can't see sharing the screen.
Or Hisa, is it possible to open everybody's mic so that each one can then unmute themselves when they want to speak? While we're waiting for others, I think there was one question from Tarek about possible applications that bridge the gaps between NLP and GIS, like geotagging. Martin, if you want to respond to this one while we wait for other comments or questions.
Maybe I can provide a brief introduction, and then Martin can complement with the technical details. And also there is a follow-up question to this also. I will combine the answer for both of them. And use of geotagging or combining text data with GIS has a long history in development field. Like 10 years ago, it started with examples like USHID and others. And also in our research, we are extensively using GIS technologies in giving a more clear let's say meaning to text data. For instance, for our dashboards, we are using GIS to visualize where the impact is coming from. Or recently we have initiated a research about poverty mapping, and we are combining the other sources of data with geographic information systems to also give a better meaning and visualization. And the lab, there is a second question about if there is an ongoing project in the lab about geotagging, I guess. And the answer is we mainly work demand-based, and there are two clients actually currently asking support for geotagging or NLP in the combination of NLP and GIS. One of them is related to poverty mapping, and the other one is an NGO that's extensively working with GIS technologies, would like to get our support in use of NLP and social media and other data sources in GIS. And we will update you after we finalize the decision about the research direction. We can update you also about this research. And Martin, would you like to add anything to this? Thank you.
Yes, can you hear me?
Yes.
So what comes to my mind when I think about geotagging, and especially social media, when we receive the geotags of tweets in the disaster context, is a valuable source of information to locate certain problematic areas. And the sentiment analysis of NLP is also a huge contribution, because we can see if people have a bad sentiment, are afraid, or is there aggression? If you talk about election problems, for example, in certain countries, violence, then I think the symbiosis of NLP and GIS is very apparent. But if you talk about data which is initially not geotagged, and we actually want to retrieve information about where is this tweet or this information coming from, it's becoming more and more difficult. But I know that there are some tools and in development that can guess the location of a person or the country based on the language they use, not specifically just a person talks English, but also by the way I talk English, for example, the machine would be able to say, okay, this person is most likely from Germany or something.
I can maybe also give some context about the recent developments. I think everybody knows, for example, speech to text. Like we use our phones and we record a voice message and it's automatically translated to text. And there's like a new field which is called image to text. And it really just started like 1 or 2 years ago. And basically, what it does, it takes an image, it detects the objects, and then it turns the objects to a text. So we can have an image and we put it in the algorithm that tells us, okay, this image shows a tree, a bicycle under the sunlight, probably in this country. And I'm just brainstorming now, but I think this is also like an intersection between image processing, the part of GIS, and NLP. And it can be used, for example, like to assess images before and after a disaster happened, to just like automate everything. You don't even have to look at the image anymore. You can just like get a text out of it. So that's pretty cool, but it's also a new field. So let's see where it goes.
Thanks, Jonas. Thanks, Gökhan and Martin. We have a couple of more questions. I wanted to raise one question from Satoko. She asked, what are the roles of the private sector in case of Vanuatu and Philippines? So if Glenn and Veron and the team could respond to that. And then there was also another question for PDRF. Let me find it. Sorry, it skipped my mind now, my eyes now. I think there was another question from Sunny on the PDF example. Sunny, would you be able to open your mic and ask your question? Sorry, I can't find it now since there were a couple of questions that popped up.
Okay, hi, thanks. Can you hear me?
Yes.
Yes.
Congratulations, PDRF. My question very quickly is, how do you fetch REDA's database? Is this automated?
Hi, Sir Sunny. Thank you very much for that question. For REDAS, the application automatically notifies us if there is an earthquake. And then we actually still wait for the official data from PHIVOLCS, and then the application also allows us to map out the affected areas by the intensity felt in that area, and that directly feeds to our risk assessment process. Thank you.
Just to add to that, Tani, REDAS is a very good government tool, which we help. So apologies for my background. Sorry. So excuse me. Sorry, I'm in a lab. I'm sorry. I'm in the lobby of a hospital. I'm sorry.
Oh.
Okay. The REDA, we help with our partnership with the government. We are able to provide this kind of training to the private sector, which is really a good tool for the private sector, especially for the business sector as well, because they get a lot of action with help in building the resilience and preparedness.
I think they're on you on mute. We can't hear you. Now you're back.
Okay, yeah. So that's it. I just added that with the partnership with the government, we were able to extend and establish or introduce this REDAS tool for the private sector. Over.
Thank you, Veron. Maybe if Glenn, you could also touch upon the question on what is the role of the private sector and the private sector network in this example that you presented. Thank you.
What we did is we were doing the vendor selection. So we went through and wanted to pick the most competent vendors to go out and make sure it was an even spread from the smallest to the largest, so that there was a localization policy of using of getting those businesses receiving the funding through from the people that received the funding as well. We did the training of those vendors. That was critically important to make sure that they understood the technology, as simple as understanding how they were going to be paid, how does the money reimbursed into their bank accounts, and also looking at the end-to-end role of a recipient of the funding of one of the Sempro cards, how they would actually spend it. So looking at selecting the transportation to get them there, and just putting a private sector or a business analysis role over the whole system. And we as we know, in the private sector, we think slightly different to those in the NGO sector. And that rollout happened on time, on budget, and a lot faster than what I think many people anticipated. And it worthwhile being involved. It was a good project.
Thanks, Glenn, and thanks, PDF team also. We have a couple of questions that we didn't manage to answer, but in the interest of time, I think we can also continue bilateral discussions. So I'm just going to very quickly go through the next steps. Jonas, if you can put the next slide. So we're going to continue this work during the next year. We are currently conducting interviews with partners and domain experts. We also, if you're interested in providing feedback to the outline that I attached in the meeting invite, we would be very much welcoming your inputs and would love to also have bilateral conversations with those who are interested. We also doing this written landscape study for review early next year. We are also onboarding data science online volunteers for this technology scoping, which is ongoing, and we are also developing these work streams further. And the next round of webinars we will organize early next year. So we would be very happy to keep you engaged and work with you on these areas. And just to also mention, we're also working with PDRF to produce online courses, for example, on GIS. So stay tuned for those, and there's a lot of very exciting work to come. So thanks very much to all the colleagues and partners, and especially the CBI member networks who joined and who presented today their great experiences. So we will look forward to this work together, and also happy Thanksgiving to everybody who's observing that. So thank you all, and we'll stay in touch.
Thank you very much also from my side. Hope to continue soon.
Thank you and have a nice day.
Thank you. Bye.
Everyone.
Thank you.
Thanks. It was very interesting.